And the next topic is, so here, as you can see, is independent component analysis, ICA. Actually, ICA has nothing to do with, like I would say, machine learning. I mean, it's part of the machine learning, but the only reason that I'm showing here is that the ICA is very the first thing is very interesting. The second thing is from name is the PCA and ICA is like is similar. That's the kind of main motivations that I'm touching the independent component analysis. Okay, so I guess most of the ICA just starting from here is cocktail party problems, and I guess this is like a famous problems we have. So probably some of you might heard of it. And say suppose you are at a very crowded parties and the music is loud, it's talking and laughing, and doesn't, let me see, it's doesn't different conversations going on around you. But however, despite of these hum, you are able to focus on one voice, you want to hear it. Actually, that's the beauty of human. Somehow, actually, I cannot explain it why or how, but somehow we are able to focus on one voice or one conversation that I want to, that we want to hear it. Right? But suppose the task that you have, you want to solve cocktail problem, party problems, like computer. I'm gonna say, trust me, it's not easy. It's not easy. It's not easy. So let's formulate it. Consider only formulated with a simple case. Suppose two conversations in the room happening simultaneously. So it's one guy is making some talking, and how these two different acoustic signals of conversation is one. So we at least we need two microphones. So it's a mixture of that. So this mic, right, in the mixture of sounds, and another mic is mixture of sound. So this is what's happening here, and what we want to do from ICA, independent the component analysis. I want to extract the original source from these. I want to make reconstruct it. That's what we want to do. Okay, so and this is S of 1 and this was S of 2. The mixture is, I mean, the easiest way to model is the linear combinations. So this is X1, X2, right? So what we want to do is that from X of 1, X of 2, we want to reconstruct it. That's what we want to do. So let's see, let's hear it.
All of you represent enormous potential and enormous possibility.
So it's got, someone is talking, Obama is talking. Some kind of music going on behind, and the mixture.
All of you represent enormous potential and enormous.
You're gonna hear both at the same time. That's right, simultaneously. I mean, here is, I mean, and I want to extract. Okay, in these situations, I want to reconstruct original source like that. I'm gonna show you the demos. So independent component analysis is that it's a linear combination of, and you can write it there. Okay, and probably you guys say like this. So it's X is I mean this, and like this. But the issue is that we don't know matrix of A. That's the problem. We don't know. We don't know. This is unknown. That's the problem. That's the problem. That's the challenging part. If we know A, just inverse of that, done. Done. The problem is we don't know A, we don't know S. We don't know A, we don't know S. Okay, that's actually it's no way to solve these cocktail party problems, I guess. So if you go back, there's some, let me see, there's some assumptions on it. Okay, but here is don't worry about it. And it's be mutually independent and the non-Gaussians, but these are the two constraints or conditions. But again, don't worry about it. So in general, there's no way that we can find out, we can do, because A is unknown, S is unknown, no way that we can reconstruct. But if we have these two conditions, hoping that somehow in the smarter way, suppose that we can do. So let's see, I'm gonna show you the demos in 5 minutes. Clear all. So what we're gonna do, so again, this is, and
all of you,
these two sounds, right? So I will say this is original sound. So this is, I just mixed it up. So
all of you represent enormous.
These are the mixed sounds. So let's skip that one. And here's in scikit-learn, in decomposition, we have ICA, but it's fast ICA. So suppose this is, I mean, we have to mix them together. So I'm gonna set matrix of A like that, but assume that we don't know. So now this is mixed. So in the fast ICA, so we have to set there's two components in it. I'm gonna do ICA. So let's say this is from the mixed one. Actually, this is reconstructive one using the fast ICA. It's amazing. And another one.
All of you represent enormous potential. And
again, this is a reconstructed one from mixed one. Suppose we don't know A, we don't know S. In general, we are not able to solve. We are not able to attack this kind of problems. But if you use the ICA, independent component analysis, although actually I didn't explain anything how to in terms of finding solutions. We can, I mean, this is one of the famous, I guess, the demos on examples using sound. And another one is we can use image. So there's two images here, some kind of image of natures and the image of my daughter. And let's mix them together. So these are the mixed in two images. And from that, take this one as input. I want to apply the ICA to reconstruct it. So here, I did that. And let's see what I got. This is the reconstructed one. What do you think? From this one, from that. I mean, how do I say? The scale might be different for each images, but as you can see, at least we can, this one, I just, from these two, take it, this is the image of natures and the image of kid and child. And let's repeat that process. It's much better. Much better. So each time there's some randomness behind, so it might be the result is slightly different. And let's do that again. Okay. So this is actually the ICAs. I mean, actually in the machine learning class, we can skip over it. I don't have to cover ICA. Again, the only reason and motivation is that PCA and ICA sounds very similar. So, but the ICA has their own the uniqueness, so that I can cover it. But I don't want to spend, I don't have enough time to spend a lot of time to explain the theory behind the ICA. But I think it's worth it to at least show what the capability that we can do out of ICA. So I show you that in actually two famous examples in Python. Okay, so that's all I have for today's